we'll now look at how to discuss domain and range for our inverse trig functions, for like arcsine, arccosine, and arctangent primarily. To understand how to deal with this, we'll recall that for inverse functions in general, I switched the domain and range between f and f inverse. Right, so this was a basic principle we saw in our previous work. The problem with this is that inverse trig functions failed the horizontal line test on their full domain. Or rather, the original trig functions do, which means that in general, trig functions don't have inverse functions. Right? This means that their inverse functions are not well defined. In order to compensate for this, we have to restrict the domain of the original function. So let's look at a visualization. Here's the picture of sine of x. But notice I'm not plotting it for its whole domain. I'm just plotting it from minus pi over 2 to pi over 2. So to put this in context, here's a sketch of sine. I'm only plotting it in this domain. So notice that in general, this will fail the horizontal line test, mainly due to periodicity. That's really what's ruining the trig functions having well-defined inverses, is this is periodic structure in the functions. So if I cut out the periodic structure by restricting my domain, then I get a well-defined inverse function because I pass the horizontal line test. So you can see here that on this restricted domain, I pass the horizontal line test no problem. So I can compute the inverse function. So notice now the domain is what the previous range was. The domain here is from minus 1 to 1. And the range is from negative pi over 2 to pi over 2. So you can see that the domain of arcsine is the range of sine. Right? The range of sine is minus 1 to 1. And the range of arccosine is this restricted domain. So I'll make a remark here that this is a restriction. And it's simply so that sine passes the horizontal line test on its domain. There are other places I could have restricted the domain to as well. It didn't have to be minus pi over 2 to pi over 2. For example, it could have been, pi over 2 to 3 pi over 2. This would have worked. In order just to make a canonical choice, mathematicians use negative pi over 2 to pi over 2. So let's, as an exercise, now work with a transformation of arcsine. Okay, so let's recall that the domain of arcsine is, well, what did we just see? We saw that the domain was negative 1/2 to 1/2. Or sorry, negative 1 to 1. So what happens when I translate by this plus 1? I need x plus 1 to be in the interval minus 1 to 1, i.e., I need this to be true, plus 1. So I solve for x, and I get that this is my new domain. It's minus 2 to 0. So this translation in the argument just shifts my domain over. In a later submodule, we'll specifically discuss this phenomenon, and we'll study how these translations affect the graph of my function. How about the range? Well, what am I doing to f here? I'm putting a minus sign on the outside. So what was the domain of arcsine? It was minus pi over 2 to pi over 2. So the range of f is what I get when I take that interval and stick a minus sign out front of it. So it stays the same. My range doesn't change in this case. Only the domain does. So let's do the same type of argument for cosine. Again, in general, cosine is not going to have an inverse function because it will fail to pass the horizontal line test. So as in the case with sine, I want to restrict its domain. I want to only look at it for certain input values. And I want to restrict it so that it passes the horizontal line test on that domain. Now, for sine, we used minus pi over 2 to pi over 2. That won't work for cosine. You'll see on that interval, I will still fail the horizontal line test. So instead, I use 0 to pi. And on that interval, I do pass the horizontal line test. No problems. And then I compute the inverse function. So notice that the range and the domain switch, as in the case with sine. The domain of cosine, we restricted to be 0 to pi. And the range of cosine is minus 1 to 1. So as in the case with sine, these switch. So let's play the same game. I'm going to take arc cosine and transform it. In this case, I'm going to put a 3 in the argument and add 2 at the end. So let's see how this affects the domain and range. So the domain of arc cosine, what is it? Well, we just saw it was minus 1 to 1. So I need 3x in the interval minus 1 to 1. That is to say, minus 1 should be less than or equal to 3x, which should be less than or equal to 1. So x should be sitting between negative 1/3 and 1/3. So that's my domain in this case. That 3 multiplier shrinks the domain down. How about the range? We saw that the range of arc cosine was 0 to pi. So the range of f is going to be everything in 0 to pi plus adding 2, because I had this plus 2 on the outside. So 2 plus 0 pi, which is 2, and then up to pi plus 2. Okay? So just to summarize, the domain of f is negative 1/3 to 1/3, and the range is 2 up to pi plus 2. So lastly, let's look at tangent. Here I'm just looking at tangent from minus pi over 2 to pi over 2. Again, this is due to the periodic nature of tangent. So I look at one period of it. And now I'm going to pass the horizontal line test. So on this interval, it makes sense to discuss the inverse function. So again, I'll switch the domain and range and get the arc tangent. So the domain of tangent was minus pi over 2 to pi over 2, and the range was everything. So these switch. Now keep in mind, I'm using open parentheses around the minus pi over 2 and the pi over 2 because I don't include the endpoints. And the reason not to do this is simply that at negative pi over 2 and pi over 2, tangent's not defined. This is where I have the asymptote. So I can't include it in the domain of tangent, which means I can't include it in the range of arctangent. And in fact, there is sort of asymptotic behavior here, where arctan gets very close to pi over 2 and negative pi over 2, but never quite reaches it. So as a final exercise in this section, let's play the game of taking a transformation of one of the inverse trig functions and computing its domain and range. So now we'll look at arctangent. So to compute the domain of this, recall from what we just saw that the domain of arctangent was negative infinity to infinity. So what is the domain of f? It's all the inputs x such that x minus 1 is in the interval minus infinity to infinity. Well, this is all x. The original domain was everything, and therefore when I apply this transformation just by shifting a little bit, the domain is still everything. Everything is permitted here. And then the range will be the same because I haven't done anything outside of arctan. So the range is still open parentheses minus pi over 2 to pi over 2. Okay? So in this case, the transformation we applied did very little to the domain and range. In fact, nothing at all. In general, doing a shift inside the function will shift the domain. But in this case, the domain was everything. So when I shifted it, I didn't see any difference. It was still everything. I did nothing outside of arctangent. I didn't do a minus arctangent, an arctangent plus or minus something, so the range stayed the same. So in this case, the domain and range of f was the same as the domain and range of arctangent. Remember that for these types of problems, there is no substitute for practice. So I encourage you to take a look at the practice questions we've written and continue to look at the textbook for these topics as you work to build understanding in this tricky concept.